Okay, so now for basically question number 2, we want to know for each operation star defined below, determine whether star is binary, commutative, or associative. So for example, you have basically part 1 of this question is on Z. You want to define a star B. A star B is equal to A minus B, right? So on Z star A star B is equal to A minus B. So what this means is that you have a binary operation star on basically the set of integers, which means that Z times Z into Z defined by basically A star B, for example, is equal to A minus B. So if you understand it this way better, then you can rewrite it for yourself so that you understand it. When I write it this way, I know that basically the ordered pairs A comma B go from the Cartesian product of Z and Z, and then they are mapped to basically Z, and basically the function is defined by A minus B, meaning that whatever A and B are that you choose from the set of integers, then that A comma B is basically mapped to A minus B. So whether you take, for example, any two integers that you take, when you subtract one integer from the other integer, of course you're going to get an integer, meaning that A minus B belongs to the set of integers, and also whether that number happens to be a negative number or a positive number, still you're covered by the set of integers, so you have no problem there. And therefore this basically star is a binary operation on Z. So that you can say. And of course, in order to write this, basically you can basically use the same sort of argument that we used in the previous video, but I want to basically save some time here. So I gave you the reasoning, then you can write it down for yourself in any way that if it's required, really. Moreover, of course, you can see that basically the star is not commutative, because, for example, if you take any two numbers A and B, meaning that if you take, for example, A is equal to 2, and meaning that, for example, if you take, for example, 2, 3, basically 2, 3 belongs to, for example, belongs to this set Z times Z, right? Now, 2 minus 3 is equal to negative 1, and 3 minus 2 is equal to 1, and basically 1 is not equal to negative 1, and therefore basically star is not commutative. And of course, by the same logic, you can show that basically star is not associative, because suppose that basically to show that star is not associative, we can basically take any three numbers belonging to belonging to Z, for example, I don't know, for example, 2 and -1 and 3, for example, right? These 3 numbers. The condition for star to be associative is that A star B star C is supposed to be equal to A star B star C. If this is the case, then you can say that basically, then you can say that star is associative, otherwise not. And using the 3 numbers that we picked as an example, you can of course see that's actually not the case, because basically A star B is the same thing as A minus B. So A star B star C would be equal to, basically, if I take this as A, and if I take this as B, and if I take this as C, then A star B would be 2 minus -1, and that star C, which is equal to 3, and that's equal to basically 2 plus 1 star 3, that's equal to 3 star 3, which is equal to 3 minus 3, which is equal to 0, right? And A star B star C is equal to basically 2 star -1 star -1 star 3, right? 2 star -1 star 3, which is the same thing as 2 star -1 minus 3 is equal to -4, which is the same thing as 2 minus -4, which is equal to 2 plus 4, which is equal to 6. And therefore, basically, star is not associative. Is not associative, right? So that's basically the whole story here. So it's not commutative, it's not associative. Next, part 2 of this question. Part 2 of this question is basically on Q. On Q, define A star B. You want to define A star B is equal to A times B plus 1, right? So basically A star B is equal to A plus B, A times B plus 1, and so of course you know that basically the product of 2 rational numbers, this is the same thing as star as a function from Q times Q into Q, right? So if this is a function and that is defined by A star B is equal to A times B plus 1, right? So if this is a function, then then star is a binary operation on Q. So in order to examine that, so any A and B that you take from the set of rational numbers, if you multiply them together, any 2 rational numbers multiplied together, that will give you a rational number. Any rational number, if you add it to 1, you are of course getting a rational number. So and therefore basically star is basically a binary operation, on Q. So we have no problem there. Of course, this whole line of reasoning, I'm not writing it down because that would take forever in order to finish all of this, and it's really not required. It's being recorded here, so you can write it down in your own words or in the same words if it's required. So star is basically a binary operation on Q. Now, in order to check whether star is commutative, of course you can see that any two basically rational numbers that you take A and B, basically in every case A and B is always equal to B times A, right? So A times B is equal to B times A, so this is going to be the same thing whether you take A comma B or you take B comma A. You're going to basically A star B or B star A is going to be equal to the same thing, and then when you add 1 to it, you're going to get the same thing. That means that basically star is commutative, right? Now that basically that basically means that, so if I were to write it down a little bit more in a more organized way, I would say that basically it is known that basically A times B is equal to B times A for all basically A and B belonging to the set of rational numbers, and also A times B plus 1 is equal to B times A plus 1. That again for all basically A and B belonging to the set of rational numbers, right? So that's basically what I said. And therefore, as a result of that, A star B is equal to B star A for all A and B belonging to the set of rational numbers, and therefore star is commutative, on Q. About being associative, then you have to take basically three rational numbers A, B, and C, and then you have to take three rational numbers A, B, and C, and then basically for every A, B, C belonging to the set of rational numbers, A star B star C is supposed to be equal to A star B star C. I can write it this way and this way, for example. So this has to be true. So that star is associative, right? So that star is associative. Now what that means is that for example, Now here you can calculate each side of this equation basically separately, and then see if they are actually the same thing, having the conditions that we have here. So A star B star C is equal to basically AB plus 1, right? And that star C, which is the same thing as basically, again, since we said that basically A star B, since A star B is equal to AB plus 1, so that means that the first number that you have here and the second number that you have here, you have to multiply them together and then add 1 to it, right? So now in this case, what happens is that this is your first, this whole thing is your first number, and C is your second number, so you have to multiply them together, meaning that you have to write AB times AB plus 1 times C and add 1 to it, right? That is going to be A star B star C, right? Now these things, if you want to think about them, I mean, sometimes it's possible to think about them in your head, but sometimes it's not. It's unwise to think about them in your head. It's better to write them down. So you already know what you can think about in your head, what you cannot. So it's always about different situations. You can decide different situations based on the situation. So for example, this kind of thing, of course, I cannot think about in my head. I have to write it down on a piece of paper. And basically A star B star C is equal to basically so whenever you come across this kind of thing, so of course the logical thing to do is that first of all you have to take care of whatever it is in the parentheses, and then whatever is outside, then you will worry about that later once you've taken care of everything in parentheses, which means that you can write this as A star. Now B star C is basically the same thing as, since we said that A star B is the same thing as AB plus 1. This was the general rule that we had for star. So then based on this, you can say that this is equal to B times C plus 1, right? And now basically what you have here is essentially again the same thing. A star B is A times B plus 1, meaning that this is your first number and this is your second number. So you can write this, I have to multiply this by this whole thing and then add 1 to it, meaning that you can write this as A times BC plus 1 and add a 1 to the whole thing, right? So now you have to make sure that, or you have to just simply examine if these are the same thing. So this is the same thing as basically ABC plus C plus 1. This is the same thing as basically ABC plus A plus 1, ABC plus A plus 1, which are actually not the same thing. And therefore you can say that A star B star C is not the same thing as A star B star C, right? And therefore star is not associative on Q, right? So it's not associative on Q. Actually, it's not associative on any set really. So but of course over there they have basically, over here we used algebra, over there they have used the example of a couple of numbers, meaning that they have used as A, B, and C, they have used basically 1, 2, and 3. You can do that as well, meaning that you can take A is equal to 1, B is equal to 2, for example, and C is equal to 3 as 3 numbers, A, B, and C belonging to the set of rational numbers. These are rational numbers because 1 you can write it as 1 divided by 1, 2 divided by 2, 3 divided by 2 divided by 1, 3 divided by 1. So these are all rational numbers, meaning that all integers are principally rational numbers. And of course, all natural numbers are all rational numbers as well. So you can pick these numbers as 3 numbers, and then you can examine whether basically A star, B star, C is the same thing as A star, B star, C, written in this way. If that's the case, then that means that star is associative, otherwise not. Now you can examine that, meaning that you can write A star, B star, C, this one, is equal to basically 1 star 2, 1 star 2 star 3, which is the same thing as basically, we said that basically A star B is equal to A times B plus 1. This was the rule that we were given in the beginning of the problem. So this means that this is equal to 1 times 2 plus 1 star 3, which is equal to basically 2 plus 1 is equal to 3. So this is 3 star 3, which is equal to 3 times, based on this, is equal to 3 times 3, 9 plus 1, which is equal to 10, right? Which is equal to 10. Now, if I write A star, B star, C, that would be equal to basically 1 star, 2 star 3, which is the same thing as basically 1 star. Again, you have to do this one first. So, that's 2 times 3 plus 1, which is equal to 1 star. 1 star 6 plus 1 is equal to 7. 1 star 7 is equal to 1 times 7 is equal to 7 plus 1, which is equal to 8. And therefore, basically, star is not associative. Right? Is not associative. So, now this kind of basically proof is basically a counter example, meaning that you have just shown that only for these 3 numbers, A is equal to 1, B is equal to 2, C is equal to 3, that the rule does not hold, right? And of course, in mathematics, if the rule does not hold for one single instance, then that means that it's not true, of course. And so it's easy to, and of course, then it's actually a valid way of showing that, for example, star is not associative. But it's not always easy. There are some situations where the situation is tricky, meaning that you cannot come up with a counter example very easily. Meaning that, for example, the counter example is hidden in, for example, there was some example that I was solving some time ago, and in the whole set of, for example, in the whole set of real numbers, there is only these numbers between 0 and 1, in the case of which, for example, some specific thing does not work. Otherwise, only between 0 and 1 and 0 and negative 1. Otherwise, wherever else you go in the set of real numbers, the whole set of real numbers, the rule would perfectly hold. There was no problem with the rule, and you wouldn't really think that the rule would not work for example, for these numbers specifically between 0 and 1 and 0 and -1. So you just simply don't know, right? And so since you don't know, of course, you cannot come up with the counter example, meaning that you would be stuck. You would be stuck. Now, in such cases, the only thing that helps and that works is algebra. Algebra actually shows you, algebra is actually is the most magical thing that I have ever seen in my life. It's a very it's like a magical system, and very magical and very powerful. It's and it's also a very mysterious system, meaning that I know how to work with algebra. I know quite well how to work with algebra, but still I'm not really able to tell you how algebra works. It's a very intricate system of thought that basically connects all areas of mathematics together. It goes from analytical geometry to calculus to arithmetic, to wherever you go. Algebra is basically connecting all of these together, and it works in all of those areas uniformly. It's very strange that it even exists, you know. So in such cases, basically the only tool that you have is algebra. And well, of course, a tool, when you want to use it, you have to know it well, meaning that it's like a screwdriver, or a specific tool that you use in order to do something. If you are to use that tool, you need to know how it works. If you don't know how it works, you will not be able to use it. Which brings us to the very important fact that you need to understand your algebra, and you need to know it well, because that gives you a lot of power in mathematics, really. Okay, so basically that's basically one example. We will continue with the other examples in this series as well. Okay, so the next part of this question is basically part 3 of the question, which is you want to basically define whether star is binary, commutative, or associative. And part 3 of the question is basically on Q. On Q, you want to define a star. You want to define a star B is equal to AB divided by 2, right? So of course, first of all, you want to know whether star is a binary operation at all or not on Q, which means that basically any that basically written in such a way that I can understand that is basically you have a star from Q times Q into Q, defined by basically A star B is equal to A times B divided by 2. So now any basically A and B that you take from any A comma B that you take from the Cartesian product of Q and Q, those would be basically 2 rational numbers. and those two rational numbers, you multiply them together, you'll get a rational number. Any rational number divided by 2 would still be a rational number, and therefore star is a binary operation, on Q, right? So you have no problem there. Next, basically, what you want to know is that whether A star B, or whether basically star is commutative, which is of course commutative because for any two rational numbers A and B, A times B is equal to B times A, and then divided by 2 is going to give you the same thing. So basically star is commutative. Now you want to basically come up with your own line of reasoning, and if you need basically these things basically exactly written down, you can always go to this tivareacademy.com. All of these things have been written down exactly, meaning that you can go to tivareacademy.com, and then you can find your way through this website, go to the class, for example 12 mathematics, and then go to that chapter, go to those exercises, and then you can download the exercises in PDF form for yourself this way, and that takes care of the problem that I don't have to write everything down on this, using this pen, which is of course not very convenient for me and would take of course a whole lot of time, of course. So star is commutative, right? Star is commutative, and the reason for that is that basically for every A and B belonging to the set of Q, basically A times B is equal to B times A, right? And so and of course AB divided by 2 is also equal to B times A divided by 2, and therefore star is commutative. So that's basically the reasoning there. If you want to know that if a star is associative, you need to that's not so simple to decide. You have to actually write it down, probably use algebra in order to check whether it's associative or not. So basically the condition that you use over there is that for every ABC belonging to the set of rational numbers, basically A star B star C has to be equal to A star B star C, and you can write this way, and you can write this way. This has to be true. This has to be true so that basically star is associative, right? So basically it's not a good idea to, I mean, whenever at this, I mean right now I'm not writing down everything, but whatever I write down, I write it down in such a way that at least I understand what I have written down, meaning that my statements have to be unambiguous and they have to be clear statements. Of course, when the statement is not ambiguous, it's of course clear statement. But at least I need to understand what I'm saying, or I need to understand what I'm writing down. Meaning that I'm not supposed to be using words loosely. For example, this is if I say that this is a function, I need to understand what is exactly meant by a function. If I don't understand what is meant by the word function, of course, you know that every term, every specific term in mathematics has some definition and some specific meaning. And that meaning has to, of course, it has to be understood exactly and properly. And it's not about basically memorizing those terms, and it's not about having some vague idea that, for example, this is how you do this and this is how you do. You need to exactly know what you're talking about. If you're using a term, you need to understand it, meaning that if I use the word function, and if I say that, for example, this thing over here, whatever that might be, is a function, I need to understand what a function is. If I don't understand what the function is, I have to go back and read everything there is about functions in order to understand that. And if that's the case, meaning that if you understand what you are talking about, then everybody else will understand you. It's just, it always works like that. You can see many, basically there are numerous videos on YouTube where people memorize things, and they use basically all of this. There is all of this these days there is basically this technology that there is something like a monitor in front of you, there is a camera in front of you, and there is something like a monitor that shows the text, for example, in large format in front of you, and then you read off of that thing, and then you talk into the camera, and then you do a video. But the person that is reading that text, of course, it's like a parrot that is memorizing something and then saying the same thing. They don't understand what they're talking about. And if you watch those videos, you will not understand them. The reason why basically you don't understand those videos is that the person that is basically explaining those things, they don't understand what they're talking about, right? So this is first of all not necessary, and this is a very, you just should not do that. Whenever you use a word, in whatever context you're using the word, you need to understand it. So, long story short, basically when I say that for every A, B, and C belonging to the set of rational numbers, this has to be true, so that basically star is associative. Now I understand at least I understand what I mean by this statement. So then I can actually work with it, or I can verify it, right? Which means that basically now I can evaluate, for example, the left-hand side of this statement, meaning that I can write A star B star C is equal to, and I know that basically A star B, based on this definition, is A times B divided by 2. I know that A star B is equal to A times B divided by 2, right? So that's the definition that we had in the beginning of the problem, which means that then you can write this as A star B star C would be B times C divided by 2. And then again, based on this definition, I can write this as A times B, which is A times this whole thing. A times this whole thing would be A times B times C divided by 2, and then I need to divide that by 2, right? So that's the same thing as ABC divided by 4. That's basically A star B star C. On the other hand, A star B star B star C is the same thing as basically A star B, which is the same thing as AB divided by 2 star C, which is basically, again, multiply these two things together, ABC divided by 2, and then divide that by 2, you will get ABC divided by 4, divided by 4. And therefore, as you can see, A star B star C is the same thing as basically A star B is the same thing as A star B, A star B star C for all A, B, and C belonging to the set of rational numbers, right? And therefore star is associative. So this was part 3 of this question. So therefore the operation star is commutative and the operation star is associative. So that was basically part 3 of this question. That was part 3 of this question. Now, let me see. 248. Part 4 of this question is on Z plus. On Z plus, define A star B. Define A star B is equal to 2 raised to the power A times B. Okay. Now, there is always some sort of notation that is not easy for you to understand, meaning that there is always some notation that you are not very much familiar with. Or, for example, in the beginning you learn something using some specific type of notation. If they change the notation, then you have to adjust to the new notation. That would be a little bit confusing. So, which means that you can write this as basically you have basically your star that goes from Z plus times Z plus into basically Z plus defined as A star B is equal to 2 raised to the power A times B. 2 raised to the power A plus A times B. Now you want to know whether star is a binary operation, if it's commutative, and if it is associative. Okay, so now you want to know basically if star is a binary operation. And so in order to know that basically, you take your A and B from the positive integers, and any two positive integers that you take, basically the product of any two positive integers in any order is going to be the same, meaning that whether you take A times B or B times A, meaning that you can say that for all A belonging to the set of positive integers, basically A times B is equal to B times A, and also for all A belonging to the set of positive integers, therefore 2 raised to the power A times B is equal to 2 raised to the power B times A, and therefore A star B is equal to B star A, right? And therefore basically star is commutative. Star is commutative. Now, of course, if you want to know if it's a binary operation, basically any A and B that you take from the set of positive integers, if you multiply them together, you will get a distinct number or a distinct output for the function, and then basically you use that as the index of the number 2, and then that of course is a function, and as a result basically star is a binary operation, and it is also commutative. Now, in order to know whether star is associative or not, so basically you can say that in order for star to be associative, basically for every A, B, and C belonging to the set of positive integers, A star B star C has to be equal to basically A star B star C. This has to be true, right? For all A, B, and C belonging to the set of positive integer, this statement has to be true. Most of the time in mathematics, we cannot prove something, or we cannot think about something because most of the time we don't really know what we are thinking about. Meaning that your thoughts are hazy. You're thinking in different directions, and your thoughts are not organized. Now, most of the time when you want to prove something, if you just simply write it on a sheet of paper that we want to prove this or we want to prove that, and then it's like, I mean, magically enough, whenever you write it down and when you know that basically you want to prove this and this is what you can assume and this is basically what the data that has been given to you and these are your assumptions, then you will basically very simply arrive at the solution very easily, and you will arrive at the proof very easily. It's very simple. But as long as you're thinking about things in your head, your thoughts can go in many different directions. You cannot catch hold of them. The velocity of your thoughts or the speed of your thoughts are so high that you will not be able to understand them. But then if you write them down in logical order, most of the time you will be able to actually organize those thoughts in such a way that you can actually use them as a logical proof. And of course, in that way, if there is any logical problem with your thoughts, you will be able to catch yourself. So basically, this statement has to be true. Now, you have to examine each part of this statement, basically one by one, and see if they are actually, if this is actually the case. Meaning that you can write A star B star C. This is equal to basically, and we know that basically A star B, from here we know that A star B is 2 raised to the power AB. We know that basically A star B is equal to 2 raised to the power A times B. So that basically means that 2 raised to the power A times B star C, and that's the same thing as basically 2 raised to the, so if A times B is equal to 2 raised to the power A times B, then this is going to be equal to 2 raised to the power basically this times this, meaning that C times 2 raised to the power C times 2 raised to the power AB, right? So that's A star B star C. Now to examine basically A star B star C, we have basically A star and then B star C is the same thing as 2 raised to the power B times C. A raised to the power B times C, which is the same thing as basically then 2 raised to the power these two multiplied together. So that's A times 2 raised to the power B, 2 raised to the power BC, which as you can see are not the same thing. So then you can say that A star B star C is not the same thing as A star B star C, B star C, and therefore basically star is not associative. Star is not associative. So this was part 4 of this question. Is commutative, is not associative. And of course over there they have used an example using a couple of numbers. Here we used algebra. It's basically the same thing. It's usually easier to whenever you're comfortable with algebra, of course algebra is much easier. But then if you're not comfortable with algebra, of course algebra would be something, well, you would not be comfortable with it, of course. But I suppose almost all the students in India, at least, almost all the students in India are comfortable enough with algebra. That the little amount of algebra that I know, almost everybody knows in India, so it shouldn't be a problem for you to use algebra whenever it's necessary. So that was part 4 of this question. Now part 5 of this question is basically on Z plus, on Z plus. You want to define A star B. Define A star B is equal to A raised to the power B. So that would be basically a binary operation from the set from the Cartesian product of Z plus and Z plus to Z plus, defined by A star B is equal to A raised to the power B. So of course this would not be of course this would be a binary operation, because any two numbers that you take from here from the set of positive integers, and if you raise any of those numbers to the other number, you will get some integer, and that integer of course will belong to, because both of them are positive, so then basically as far as being a binary operation is concerned, so you have no problem there. You have no problem there. But then to check whether basically star is commutative, basically the condition is that basically the condition that A star B has to be equal to A times has to be equal to B star A for all A and B belonging to for example to some set A, for example, or to some set B, for let's say in this case Z plus, for example. This condition has to be true, right? So this has to be true. Now in this case A star B would be equal to A raised to the power B, and B star A is equal to B raised to the power A, and as you can see A star B is not equal to B star A, and therefore basically star is not commutative. Is not commutative, right? So that's one part. And basically to check whether basically star is associative, basically for all A, B, and C belonging to the set Z plus the following condition. You need to excuse my handwriting. I just want to basically, I mean, you understand when I say following, so you can hopefully read my handwriting. It's not very easy to write with this pen, and if I want to be very meticulous with this, then that will take a long time to write down everything properly. So the following condition has to be true, and the condition is that A star B star C has to be equal to A star B star C. And you can write this way, and you can write this way. And so now you can check this. Basically you can write A star B star C is equal to A raised to the power B star C, which is the same thing as this raised to this power, which means that A raised to the power B whole raised to the power C, which is equal to A raised to the power BC. And A star B star C, A star B star C is equal to A star B raised to the power C, and then you have to raise this to this power, meaning that this is equal to A raised to the power B raised to the power C. Which is not the same thing as A raised to the power B times C, and therefore basically A star B star C is not the same thing as A star B star C. That's not the same thing, and therefore star is not associative. Therefore, star is not associative. And finally, the last part of this question is, well, I'm going to end this video here, and then we will continue with the last part in the next video. Thank you.